Hello and welcome back to a new video here in my C++ tutorial series on the Ludwig Fusel channel. In the last video basically in the last videos, we have talked about how to shape our newly written function precacher class and our newly written precache container class to completely fulfill our needs. So we moved everything into functions, overloaded operators, talked about the big five and how this all gets together to be nicely and automatically managed without us having to worry in our code. So the idea was, well, we wrote everything, and then inside of our save main, we can just write that little piece of code here, which is quite short, and it does a hell of a lot of things in the background. That the classes are very versatile, they pre-compute data, they allocate memory, they manage their memory on their own. It's really a joy. We can really use it, and it works. It just works, right? It's simple, easy syntax, and it works. Now, as you can see here, like, this is quite big. We have the function f, we have the classes in here, all the functions, the operators here for printing these data out. I mean, see, like, until we get to our main code, it is really, really big. And that's what we're trying to solve today, right? Today, we want to move this all out from that one big file. You can see like 280 lines. It's okay, it's not that big, but still, in terms of a logical segregation of our code, it's not really how we would expect it. So today what we want to talk about is how we can move that off to a custom code. Now, the first thing that I am always doing is I am creating a file per class, and that's also a very common thing that I would recommend you doing it. If you are creating a class, create your own file for it. So the function precacher, it's a class called function precacher, should all go into the own header file for that, the own file for this class function precacher. So what we now want to do is we now want to create a new file where we can put everything in here. Now in C, if you remember that, for example here at the ini parser, we have created a .h and .c files. So for example, the ini parser.h had all the function definitions in there, while the ini parser.c had all the implementation here. So declaration and implementation, or however you want to call this. You have like one file with all of the code in there and one file with just the signatures, how everything looks. Now we can do a similar thing in C++ as well. So in C++ we also have C++ source code files. In C++ they are called .cpp, and in C++ we can also create header files. Now as you can see, in C we had C, and in C++ we had cpp. In C we had h, so in C++ it would be quite obvious to use a file called hpp, and that's exactly one idea that you can do. Now you can actually see that if I want to create a header file inside of Visual Studio, you can actually see it creates a C++ header file, and you can actually see that Microsoft suggests us to just use the file name .h. And this is in general totally fine, but I want to show you multiple ways. Okay, no, that's not the right thing. I thought I copied that function precacher, and we want to call it .hpp. Now, really, the file extension doesn't matter for a header. It does matter. However, there are several tastes that you can use. So in general, let's maybe get up an editor here, Notepad. Come on. Oh, Windows is again slow. Let's get up a Notepad here. Now, in C, let's just call this isots C, just that it looks a bit better. Now let's just call it C. So in C, our source was in .c files, and our header were in a .h file. Now in C++, you can see that we put our source in .cpp file, and thus we would also put our headers in a HPP file. This kind of like makes sense. However, what you're always going to find as an alternative is that the people also put the C++ header in .h files, and in fact I am doing it as well. I'm personally the guy that always puts his C++ headers in .h files. However, you can also use HPP files. Now in general, file names on C++ is a whole different story. On C it's quite simple. Source.c, header.h. On C++ it's a bit different. Now in C++ you have many favors. For example, you have the HPP CPP favor, you have the H and CPP favor that people are using. You can also name your files I forgot now all the dots here, but that really doesn't matter. So .h and .cpp. You can also name your files .hh and .cc. You can also have them at hxx and .cxx. This is also possible. So really in C++ you have many favors on how people like to do it. Like the most simple one is a .h file and a .cpp file, header and CPP. The bit more strict version .hpp.cpp, or the a bit shorter version HH and CC, which is just basically doubling what we had in C with H and C, or here for plus because plus is also often like seen as this X because it's like the X is like a rotated plus, H XX and CXX. Really, as you can see, we have multiple flavors that we can use, and what I personally just gonna do for the tutorial series, for this tutorial series, I'm gonna use HPP and CPP just to separate this. Privately, if I'm doing this at home, I'm always using .h and .cpp because it is more simpler, and I'm just used to it, having it as .h and .cpp, but in the tutorial series we're going to use HPP. Now what we're going to do, well, it's going to be very simple. We can just copy all the code from the function precacher, so just Control X everything out here, and just Control V paste it in there, press Control Z so that you get your formatting, and boom, we are done. All of our code is in a different header. Now of course we are missing a few includes here. Mainly the issue are the integer types. So it's cstd int that we are missing. So let's include this. Hashtag include cstd int. And we should have all the functions available. Okay, we are still missing the exceptions and the mem copy. So cstdlib and exception is required. So let's hashtag include cstdlib, and cstdlib should give us the mem copy. No, it's not in cstdlib. It should give us the malloc, that one. That one should give us the malloc. Okay, actually no, we haven't used malloc, we have used new here. So cstd's cstring actually, no, it's called cstring. Now in cstring we have the mem copy. And now we are needing the C++ exceptions, and there's some convention that says first the C++ include, then the C includes. So std except is the C++ header for the exceptions, and now we have some basic data in here. One thing might still be missing. The O stream is kind of recognized, but you can see that the cout is not. The cout, actually also the std handle is not there. So we are kind of like missing a few more things. We are missing the IO stream, which is the stream for input and outputting data. So let's include IO stream here as well. If I add IO stream, the functions down here should also be without any issues. Alright, so this concludes the first step that we have done. We have moved our code outside of the main file. Now, as you can see in the main file, we're gonna of course get some errors because the function precacher is now no longer used. How can we solve that? Well, the idea is to basically just include our local header. So I'm going to include the function precacher.hpp, and you can see that as soon as I include it, everything is back to normal. If I would run it, press F5, it should also compile and execute without any issues. Alright, 5 still does everything what it should do. Okay, so let's continue on and also do it for the container. So let's create a new header file. How did I call this? Of course, I have not the name in here. Precacher container. Let's copy this over. No, not the class wizard. That's something that is there. There's like this class wizard which tries to help you creating classes, but I personally don't like what this class wizard is doing here. So yeah, what I personally just tend to do is add everything on my own. I don't think that really anybody is using this class wizard. And there we have the function precache container.hpp. Now here as well, just gonna collapse this so that I can cut this easier. And then I can just paste this in here. Now you're going to see that we have a few more issues there. You can see that we have, of course, we are missing cstd int because I think we are using ints. Are we? No, we are using just C++ features, but still I wanna. No, if we don't use them, we don't need to include them. So really, what we are missing is again IO stream and the cstd accept, and let's include that. IO stream.cstd accept, it's like just called std accept because it's just C++. Adding these two in here should solve the main issues with that, and now we should be just left with the last issue, that the function precacher itself is not included here, and that is something that I always like to do before my libraries. So my own code always comes before the libraries. function precacher included in the precache container, then the system libraries, and we should be good, and we should have everything included properly, and we should have no errors here. Now the main file of course still has errors, and I of course violated my own rules there, so let's do it like that. And now let's also include the container. Let's include the precacher container here, and you can see again that everything is good. Now the same then, I haven't told you that again, then in C, this pragma once is still important on C++. Pragma once still a thing, still required. Just keep it in there, it's important. Now, as you can see, we now have boiled down our main on quite a much. There is quite some code gone. And you can see that now everything is still working, and the main file is way smaller, like just 60 lines. Let's do 5 and 5, still doing the same thing, everything is good. However, we are still not done here. You can see that we have these print operators, these shift operators for printing the precache container and the function precacher. These are of course also features that should go into their designated header files. So the function precacher should have its own shift operator defined as well. If I remove it here, it's gonna give us an error in the container because the operator is not defined. It should give me the error. No, it doesn't give me the error because I'm not actually using the shift operator here. Actually, what I should do here as well is just use that one, right? And this wouldn't work here now, but this is gonna work again if I paste the operator down in here. If I paste the operator in here, this one is now going to work again. We're going to do, of course, the same thing with this operator. And now it's important that you do this after the class. So you're defining the class here, and down after the class, you're going to write the free-floating operators that operate on that class. So yeah, just simple like that. And if I go back to my main, again, a few lines less, and the main itself should still work. 5 and 5, and everything is good. Now you can see actually that our main has been boiled down quite a lot. Now std accept is something that we personally no longer need here. We just can use the plain exception. Std cstd lib is also not required because we are not losing anything from the std lib. We are just using like the exception here, which is inside of exception. We are using std int because we are using the integer values here, and we use iostreams to print and read. So this is everything that we should modify in our main file here to make the main file look like it should be. So just everything that it needs. Just these 5 includes the function f that we defined, the save main, and down here the normal main. Now let's actually hop back to our precache container.hpp and try to make this a bit better, because at some point we want to write proper code in C++, and proper code needs to be written properly, of course. Now, do we have an issue with that code here? Yes, actually we have. The problem is again that we are doing everything in the global namespace. The precacher container is inside the global namespace. So if any library developer on Earth decides to call a class precacher container, my code will not be compatible with that library because my code is in the global namespace and the library might also be. And this is why we should, as a C++ developer, should always put everything in a namespace, even if we are doing a simple application. In an application, this might be arguable that you don't need it because every library should have everything in a namespace. However, if you are then dealing with C libraries, you can still have name clashes. So this is why in C++ we're going to always put everything in a library, in a namespace. In this case, the application is called simple CPP app, or just in short simple app. So what I'm gonna do is I want to put my class, my own class that I have implemented, in my simple C, or in my simple app. Just let it call it simple C, simple app. Now, how I'm gonna do this? Well, I need to define my own namespace. I need to tell it that it is inside of the namespace. You all previously saw that namespaces are like done with these double points, so you would be arguing that we just do something like simple app. However, this is not how C++ works. You cannot just define a class like that inside of a namespace. This would be a quite handy feature, but this is not how C++ works. C++ works by defining the namespace as a own dedicated keyword. So what you're going to tell it is you're going to tell it the keyword namespace, and then you're going to give the name of the namespace. In this case, it's the simple app. Now in here you could go deeper, so simple app like executable. You could go deeper here in this namespace, but that's not the point here. Like, the point is that you define the namespace here. Now, as you can see, this doesn't work. If I would make a semicolon, it still wouldn't work. The namespace is actually like a kind of like a range that you're defining, and you are defining this range by adding the curly brackets. If you're adding the curly brackets, you kind of like have this range or this block of code, and everything that's inside of here will be inside of that namespace. Now, of course, this executable is not required. I'm going to remove this. Actually, if you are having issues with these double point namespaces, make sure that you are on CPP 20. I think on CPP 70, if I would go like one C++ version back, this might be an error here if Visual Studio refreshes that. Let's try this with rescan solution. Or have they added this in CPP 17? It can also be that they have added this in CPP 17. Seems like it. But the idea is like this is not available on all C++ versions. If I would go a bit back, even like 14 or something like that at some point, the syntax, yeah, there you go, is gonna fail. This is not gonna work on old C++ versions. This works on, if you have seen recently, on 70 upwards to 20, but we just care about 20 here. We are modern developers. We write on the latest language. No point in, if you're learning it, learn an old version. So this is what we do it. In this case, I just want to call it a simple app. And what I'm basically going to do is I'm just going to put this whole class inside of it. So I'm going to cut the class out of here and paste it in here. I do going to press Ctrl Z because it is formatting this a bit bad. The only issue that we have is now that all of the code is like one level behind. So I'm going to manually give that one more indentation, and now we have the pre-cache container inside this namespace simple app. Now, as you can see, this is going to give us multiple errors, but before we're going to get to them, I want to do quickly the same thing for the function pre-cacher. So here as well, let me grab the whole class. Let's write the namespace here, and actually if I start typing, you can see and press Control Space to give me suggestions. You can see that it actually scans our whole solution, which namespaces are available, and we can use autocomplete here. Now just paste all the class in here. Sadly, it doesn't keep them marked. Has it tried to automatically fix my indentions? It kind of tried, but it kind of also failed, or it didn't fail. It did what it thought is good. In C++, actually, Visual Studio thinks that by default we can actually change this, but I haven't bothered here in the VM, that the private and public should be at the same level than the class. I personally like this one level deeper, but this is, again, these are just like all these indentations, new lines, semicolons. If you put something in a new line, in the next line, in the same line, this is really all depending on your flavor, on how you like the code. I like it like that. That's just how I personally think it's good, but you could have a different opinion on that. All right, so now that we have modified this code, we can actually like collapse this node down a bit. We're gonna notice a few issues that we have. The first obvious issue is that these operators down here are no longer working. Well, this is the case because they are inside the global namespace, and inside of the global namespace, function pre-cacher is not a thing. Now, if you would move these operators inside of here, this would work again. However, if you have this operator in there, it's going to give you other issues. The problem is if you have like this stream operator inside a namespace, you always need to specify the namespace, and it's no longer going to work automatically by just writing the operator. This is why, at least if you're going for printing with the O stream, you always need to define this operator in the global namespace. It's always required that this is in the global namespace. They have a dedicated class here, so they are not going to have issues with overlapping functions. And the only thing that you really need to do is you need to specify the full path to the function precacher. So simple app function precacher PC. Now you can see it works again. Go in here. Should work as well. Now note that the precache container does not require the specification for the function precacher, because by default you are always in the current namespace. Because this class is stored inside of simple app, it has access to the how did I call this, function precacher. Now by default, if you are inside of a class, the first thing that it tries to find is something defined internally in this class. So if you have like a variable, a name, a function, it is always trying to find this at the current level. So it tries to find this in the precacher container, and if it can't find that, it hops up to the simple app namespace. If it can't find it there, it goes one level above. So the idea is basically you're always going to get the most concrete functions. So inside of your simple app, you're always going to get members of your simple app. If you would have another class, like if I would have the, how is it called, function precacher, if I would have another function precacher, I do not need to private implementation just to show that. If you have another function precacher on that level, it's not going to use it. If I hover over that, you can see it is a class simple app function precacher. If you want to go to the global namespace, you need to prepend these double points. If you prepend these double points, you now can see it's the class function precacher, which is like that one defined above here, which really doesn't do anything. You can use these as a prefix to go to the global namespace, and then you can of course always go back and deeper in it. But by default, it's always trying to find this at your level, where you are currently are. You're at the simple C app, so by default it tries to find it in the simple C app, and you can see it uses the correct one, and you don't need to specify the namespaces, and that's the beauty of namespaces really. It's in general automatically doing that. If you are using this inside of your library, inside of the code that you write, if you're always inside the simple C app namespace, everything works just if it was in no namespace at all. But it does not conflict with some code outside of the namespace because it's a different namespace, and if you want to use it from outside of a namespace, you need to explicitly state that. Which actually brings us to the new errors that we have created. We have a hell of a lot of errors here. We have all these errors in here because you can see that the precacher container is no longer in here because we are now inside of the global namespace, but the precacher container is in the simple app. Now, you could do this now by just always providing the simple app here. If I do this here and here, if I do this there, you can see easy. It works now again. I can hit F5, compile it, and start all over. However, this is not very clean because we are in our save main. This save main is associated with our application. So actually what we rather want to have is that all of that code is inside of our application, inside of our namespace. So what you could do is you could also wrap this with a namespace. So what I tend to do, just put a namespace in here, simple app. Let's actually keep this one open here so that we don't need to copy that much. Let's move them all like one indentation level higher. And let's make a closing bracket down here. And now the only thing that we would need to change, now let me quickly get rid of these again, because these now should work, because we're now in a simple C app namespace. And now the only thing that we would need to do in the main is we need to put the main inside the simple, like that one. You need to kind of like put a namespace in here. It is not possible to put the main actually in the simple app namespace, because if the name is inside the simple app namespace, the compiler can no longer find it. The compiler searches for the main function in the global namespace, and if there is no main in the global namespace, it is not possible to link these together, and that's just something you need to be aware of. Now, actually, after all that coding that we have done now, you might have one big question. And that one big question is, why did we not create a CPP file? Why have we written everything inside of a header? And the answer to that is because we can. And we also need it for the next video, but that's a different topic. Now, the joy and the beauty of C++ is that you don't need C++ files. In C++, you can just write everything in header, which is then later on called header only or header only libraries. Now, this is very beautiful because basically what you are doing is everything is just in a header. And as I told you, a header does not get compiled, which means that you don't have pre-computed code, which means that the only code that's been generated is inside of main.cpp and everything is together in one place. This is amazing, especially if you're using a library, because if you're using a library, you can customize everything. You can customize namespaces, defines. You just need to do everything before you include the library. And if you do it, it's all compiled inside of your main and everything is ready as you desire to use. However, there are also of course, not only good points to that. A bad point is that you are increasing your compilation time. Imagine you have 15 libraries used, and every library is built up out of 20 files, which are each like 6,000 lines long. And if you then have in your own project 10 C++ files, each of these 10 C++ files need to parse these 15 times 10 times 6,000 lines. So in general, if you have headers, they are all processed in your C++ files. So depending on how many C++ files, it means that you are computing data twice, because you need to process the header twice, or even multiple times. If you have like 3 C++ files, you need to process each header 3 times and compile each header 3 times, which is bad, because if you are recompiling this every time, it is costing you time. And especially if you're using libraries, and I do have a project where I have just like, I think like just only 2 header-only libraries, but still these 2 header-only libraries are massively increasing my compile times. And I'm personally, I previously, like, header-only libraries are simple. You just download them, you copy them to your project. If you have a package manager, you just include them. You don't need to deal with builds, you don't need to deal with runtime versions and multi-thread debugging and all the madness that comes if you are pre-compiling code in a static or dynamic library. There are like so many things you need to be aware of, especially if you're having external code pulled in. You don't need to deal with them if you have header-only libraries. So especially if you get started, they are amazing. However, on a big project, they can be a pain because they dramatically increase your compile time. Currently, this will be totally fine, especially for learning. However, this is not the main reason why I'm doing that. Actually, I would love to show to you how we move them into C++ files, but we're going to do this, of course, later as well. I'm going to show this to you how you do it with the function in a second. But the idea is, next video we're going to talk about templates, and templates only work in headers because they're not allowed to be compiled. In general, you can, of course, move all that code into designated source files. And I'm going to show this to you how this works in theory later on in the tutorial series. But for now, we're just going to keep them in the headers here. And everything is then good. Now, actually, our code has one potential point of failure that we haven't addressed yet. And the point of failure is this function down here, or this function down here. The problem with these functions are that they are inside the global namespace, and they are not classes. Now let me actually show you when these functions are going to be an issue. Let me actually create a new file here, and let's just call this dummy.cpp. And instead of dummy.cpp, let me quickly include the function precacher and write a int lel. This int lel, or let's actually write this like a void lel, and the void lel is going to create a function precacher pc, and I'm going to use iostream here, and later on down there I'm going to do a stdc out of that pc again. Now if I would compile that code, we're going to get an error. There we go. Now these are like potential points of failure that are going to cost you hours of fixing them. What is the issue here? Well, the issue is, let's take a look at this. Class, std, basic, ostream, char, struct, std, char traits, char, ampersand, underscore, underscore, decal, operator, shift, class, std, basic, ostream, char, struct, std, char traits, char, ampersand, class, simple amp, function, precacher, const, ampersand, open bracket, question mark, 6, @ sign, y, aa, eav, and so on, already defined in dummy.obj. This message, especially if you're new to programming, is hard to fix. But the solution to it is simple, and the explanation as well. First of all, let's assume, or let's take a look when this error occurs. This error code starts with LNK 2005, and LNK stands for linker. So this issue arose during linking. This is not a compile time issue. The compiler, which processed the dummy.cpp and the main.cpp, was totally fine. The compiler processed both of these files, and both of these files were processed and compiled correctly. So we have two binary code. So we have two binary code files that were produced that are totally fine. So 2 times binary code that is correct. However, we're going to get an issue when we try to merge them together in the exe. And why do we get that error? Because something was already defined, or down here at the second message, one or multiple defined symbols found. Now, the problem that really happens here is that we have written these functions as they are. Now, we use them with the function precacher, so let me use that one to explain. So basically what's happening is that the compiler processes main.cpp. Main.cpp sees this operator function with pcprint and return at OS and generates binary code for it. Now, the compiler also processes dummy.cpp. Dummy.cpp also sees the stream operator here and also processes code for it. And both of these code files are just normal functions that are looking the same. They actually look like what has been written inside of the brackets here. This is actually how the function looks later on in the binary object. This is just an obfuscated way of telling how this looks with like namespaces and function names and function signatures. It's like all encoded inside of this string that we have down here. And what then the linker does, it finds two of these implementations. So it finds the implementation that has been compiled inside of dummy.cpp, and it finds the implementation that has been compiled into main.cpp. And what it tries to do, it tries to merge these two together. However, it founds this implementation 2 times, and since it has this implementation 2 times, it doesn't know what to do. And this is why it says multiple defined symbols. Or, as you can see, it tried to match the main.obj because D is before M in the alphabet, so it first has processed the dummy.obj and then it processed main.obj, and when it was inside of main.obj, it found that this function was already defined in dummy.obj. So in dummy.obj, this was already put into the exe, and so it cannot be put into the exe from the main.obj. Now, I hope this is understandable, but if you have listened to what I've told you, you should be confused why it worked previously and why, or no, not even that. You should be confused why it doesn't work for this function, but it works for the class, because the class has also functions and the functions are also the same. Why on earth does it work for classes and but not for functions? Well, again, this is working because of dumb compatibility for C. Everything that was working in C or was not really working in C was tried to get into C++ as well. And really what's happening is if you're writing a function, and really what happens if you are writing a class is that each function of that class is kind of marked with a flag, hey, this is a class. If this is already defined, ignore it. And this doesn't work for functions. On classes, it's basically just ignoring that. All right, basically what happens is it reads that there's a definition for the class and it says, all right, okay, this class has already been defined, so I'm not going to try to include these functions. And then it's basically going to skip the functions of the class. This is why it works for the class. However, this does not work for the functions. Why does it not work for the function? I can't tell you. I can tell you why they not doing this by default, also for functions, why they're not taking a look and say, all right, it's already been defined. Probably because of libraries, and if you have multiple versions of the library or compiling the library twice, and stuff with static and dynamic linking, it's probably something like that. However, we not want to go into depth with that here. But on functions, this doesn't work. However, we can tell the compiler to do it. We can give it a little keyword called inline, and if we give it the keyword inline, the compiler will go into a completely different mode. Now, inline basically means try to copy and paste the code. So instead of actually generating a function, the compiler tries to copy and paste this code where it was placed. So in general, it just tries to call PC print with stdc out. Really, that's what the compiler tries to do if you are defining this as inline, and that is what it's probably going to do. It's not going to be guaranteed that it does that. It might also generate a function. However, it tries to copy and paste this. However, if you want to copy and paste something, you need to have it available. And to have it available, it needs to be in the header. And if you have this in the header, and you maybe want to generate a function, or you maybe want to copy and paste that, it is kind of like a contradiction to this error that we have. So basically, by providing inline in here, the compiler is gonna guarantee you that it either copy and pastes that, or that it doesn't care if it is defined multiple times. And that's the only reason we are doing this. Either copy paste it, or just ignore if it is defined multiple times. So really what we do is we want to add this inline to every function. In general, if you have a function that is implemented in the header, if it's implemented in the source file, it's a whole different story. If it is inside a CPP file, no problem. A CPP file, if you just have the signature here, it's defined somewhere else, load it later. But if it is defined in a header, and it's just a function, no matter if it is in a namespace or in a global namespace, if it is a function that is not inside of a class and you define it directly in the header, directly have the implementation here, just always put this inline keyword there. You can also put the inline keyword in classes. Actually, what you can do, for example, for the size function, you can give the compiler the hint and tell it to inline that. And if you are writing an inline in here, it's telling the compiler, hey, maybe want to inline that. By default, the compiler probably, if you're on release, has already inlined this call because it's just accessing the usage. Inlining means removing all the overhead of the function calls. As I told you, copy and paste it over, remove the overhead of calling the function and going there, going back, just directly read the data. You could put this a hint in here. It's probably not gonna change anything if you're on release and try to optimize your code. But in general, what I personally do, if I have a header only class, I write no inline in the class. If I have a header in the CPP file, I'm gonna write inline before every function that is inside the header, because I'm only going to write functions inside of the header when I have a CPP file if they could be inline. So I'm going to always explicitly define the inline keyword there. But in this case, it doesn't matter because we have everything inside of the header, and then this inline would be rather disturbing. But here it is required. If you have a function, you always need to write the inline. And if I recompile that one, you can see it compiles, and it also completely finishes it. The simple CPP app exit was generated. Even though we still have the dummy.cpp in here and it's compiled, it doesn't care because it has the inline keyword, and thus it kind of like ignored that it was defined multiple times. Right, that's the idea behind that. Now I want to do one more thing here. Actually, what I want to do is I want to move these two functions, the function f and the save main. I want to put these two functions inside of their own file as well. We have that main.cpp, and I want to put these ones, because they're like different than main, I want to put these one in their own files. And this is actually where we're now going to create a pair of files. We're going to create a header file and the source file. So I'm just going to call this one simple app.h or simple app.hpp. And what I'm going to do here is I'm going to add another item, a source file, and I'm going to call this one simple app.cpp. So now we have a header and the source file. In the CPP file, I'm of course going to include that one, and inside of the simple app.hpp, it's going to be quite simple. Let's do a namespace simple app here. Inside that, let's copy over that code here, so from f and the save main. Let's get them out of here and let's remove them from there. Let's save that. Let's go to the simple app.hpp. Let's paste them in here. Let's get some includes. We don't need the integer actually, and iostream is required and exception is required, but int is no longer required, so we can take int down there, but we also gonna need iostream in here. And that's all good. Now instead of main, we no longer need these two. So we want to put these two inside of here. But what we're going to need inside of our main is we're going to need inside of our main our simple app.hpp. So I want to include simple app, and this should make the code work again. Now the only thing left to do is to migrate this into the C++ file. The function f, I'm just going to inline it because it's very small. Actually not, it's going to be generated. Now, I'm just going to inline this because I don't want to have too many code here. Does Visual Studio already support moving that? I don't think so. Can I? No, I can't not really do this. So to move that implementation of the save main into the source file, I do need to manually do this. So what I'm manually going to do is I'm going to remove the code from here. And I'm just going to write a signature in here in save main. And instead of the simple C app, we need to implement this. Now, if we are main namespaces, it's not really different to what we had previously. We write a return type, then we write a function name, but now the function name also concludes the signature. So really, we do it like that. Not the function name, the namespace name. So the namespace and the function, full qualified name, and we're going to paste the code in here. By the way, if you would have a class like, let's do this quickly, like the class X, which has a public void do work and maybe a constructor X and a destructor X. If you would have something like that, it's also similar to that. If you would want to have an implementation in here for the constructor, it's just going to be simple app xx, just like that, because the constructor doesn't have a return value. Destructor is going to be similar, just that we have like the signature like that. And if you have a return value, just void simple app x do work. And the signature, of course, needs to be also there if I would have a parameter like an index, something like that would be, of course, also be required to have here index. So that's like the idea if we would have a class, right? I told you that we're going to do this later on in the tutorial, but that's the whole idea behind that. You just need to have the full path to that name. You could also specify namespaces here, but I personally don't do this. You could do like namespace simple app here, and then you could move this code one level back, close the namespace here, and then remove it from there. This would work as well, because, yeah, again, you are inside of the namespace simple x, and it then would redirect you to simple app xx. If you would go to the global namespace, of course, it wouldn't work, so then you would need to redefine this again. But that would be the idea of how you would move your code of a class inside the C++ file. Now, again, of course, this is all not required, but that's the whole idea here. So you can see we have the function f here. We could bother in moving them down later as well, but I don't bother here yet. And if you do that one, it's really simple, and it's all a bit more separated, right? It's a bit more separated. You do not never need to take a look at your main again. And if you want to take a look at your main, you can see it like just the implementation of the try catch. And if you want to edit your app, you go to your simple c app.cpp or hvp. You have your whole application code in one function, one single C++ file, which is properly inside of a namespace. The function is inside of a namespace. We don't need the function to be inside of a class. You could write a class like Java, but it's really no point in doing a class there. There are points of doing classes, like main classes, but the idea of the main class would then be rather that all of this exception handling is done in the class, and then you're extending this class. But that's a bit advanced. We haven't talked about this yet. So in general, what I want to talk about today, if we have seen that this code still works, of course, because we haven't ratified that, but again, it's still going to give us the same output. I think, like, what is that like now? 2 or 3, 4, 5 videos that the code completely behaves the same, but we radically refactored it, somehow, something like that, but yeah. So, right, the idea that you can see is your code gets a hell of a lot more structured. A lot more precise, small files that tell you what's going on. Small files, if you are changing a thing in one C++ file, not everything needs to be recompiled. For example, main is probably never going to get recompiled again, ever, in our whole journey of that lifetime of the simple CPP app, which is just going to be one more video, but yeah. It's never going to be getting recompiled if it's already compiled. If we do a change here, the simple app.cpp is the only thing that really gets recompiled, which is really just what main does, and really just what changed. We don't need to recompile the exception handling every time. Later on, this is getting even more drastically if you are writing classes and you have like the implementation of the classes inside your CPP files. If you change something, a small change on the class, on maybe a container linked list or something like that, just the small section is going to get recompiled, but not the whole class. So it's really, really handy on putting your source into multiple files. Now, this is why I personally don't like this HPP and CPP style, because they look so simple, so similar. I personally would have had this to be something like that, but general, here we are doing CPP, so we won't want to keep the syntax. Alright then, so this concludes this video about headers, source files. Quite a long one, actually, for not archiving much, but still, a bit of namespace madness, a bit of operator namespace madness, how the linker works and stuff like that. So I hope really helpful for you. So yeah, hope you enjoyed. Thank you for watching. See you in the next video, and make sure to like and subscribe. Have a nice day. Bye.